Alright, welcome back. Here we go. So we're finding domains by combining functions. So let's take f of x equals x squared plus 9. And let's take g of x equal to the square root of x minus 3. So when we combine functions, let's say we add these two functions, f of x plus g of x. Although the addition of the two is pretty simple, x squared plus 9 plus the square root of x minus 3. We have to take into account the domain for each function. The domain for f of x is all real numbers. It's a polynomial. For g of x, being that it's a radical, we have to take what's underneath the square root, set it greater than or equal to 0, and for that we get a domain of bracket 3 to infinity. So when we combine these two domains to satisfy the function f of x plus g of x, the domain is bracket 3 comma infinity. What works for one has to work for both. So it takes on this domain for the function f of x plus g of x. So let's look at two new functions. F of x equals 1 over x squared minus 1, and g of x equals, that's g of x, sorry, g of x equals the square root of x minus 2. And I want to find f of g of x, so a composite function, and that is the same as writing it in this notation, where again g of x, g of x is the input for f, so we're going to take g of x and plug it in. So when we do this, we find f of g of x, that equals 1 over the square root of x minus 2 squared minus 1. Now, at this point, you always need to consider the domain of g of x. Whatever is restricted for g of x will stay restricted to your new function, even when simplified. The domain of g of x is 2 to infinity. So when we simplify f of g of x, we get 1 over x minus 2. The square cancels the square root. So x minus 2 minus 1 equals 1 over x minus 3. So this is our final function. This is f of g of x. There is a new restriction that pops up here, and that would be that x cannot equal 3. So our domain, I'll write it down here in the corner, for our new function is bracket 2, comma 3, parenthesis, union 3 to infinity. This domain here, if you're prepared for something like this, I think you'll do well in the midterm. If you have any questions, you can ask me in class. Thanks.